Hi, I am Sufyan Makhlouf. In this video, we're gonna do the partial fraction decomposition of this fraction. By the way, notice that the denominator degree is greater than the numerator degree. So the polynomial in denominator has two sample roots, 1 and 2. That's to say it has only two linear factors, x minus 1 and x minus 2. So its partial fraction decomposition is only the sum of two simpler fractions, a over x minus 1 plus b over x minus 2. So we have two unknown, a and b. So our challenge is to find the constant a and b. So we have two unknowns, a and b. So how many equations do we need? We need two equations in a system to solve. I will give the simplest method by giving the simplest equation. Here we focus on the constant a. We will look for a. Take a look closely. By which factor do you multiply the fraction to eliminate the denominator to disappear the polynomial below this constant a? Note f of x. So f of x multiplied by this factor x minus 1. So here we eliminate x minus 1 for the first on the left side, and here when we multiply by x minus 1, so we simplify by x minus 1. Here we get a plus this term times x minus 1. This equality is true for any real x different from 2. Then what is the best value of x that gives a? So here when we take x equals 1, so here 1 minus 1 is 0. So the best value of x is x equals 1. So here we have 2 times 1 minus 7 over 1 minus 2. Here a is a constant, plus here b over 1 minus 2 times 1 minus 1, which is here 0. So a is equal to this fraction, so equals 2 minus 7 is minus 5 over minus 1, that gives 5. So a here is 5. Now we focus on the constant b. We will look for b. By what factor do you multiply the fraction to eliminate the denominator to disappear the polynomial below this constant b? So here f of x is multiplied by x minus 2. So this term gives here we simplify by x minus 2. This is equal to a over x minus 1 times x minus 2. And here we have x minus 2 over x minus 2 is 1. So here we get b. This equality is true for any real x different from 1, because we can't divide by 0, because 1 minus 1 is 0. Then what is the best value of x that gives b? So here if we take x equals 2, so here 2 minus 2 is 0. So 2 is the best value. When x equals 2, so here 2 times 2 minus 7 over 2 minus 1 equals here a over 2 minus 1 times 2 minus 2 plus here b is a constant plus b. So this is 0, 2 minus 2 is 0. So b is equal this fraction, which is 4 minus 7 is minus 3 over 2 minus 1 is 1. So that gives b equals minus 3. So the partial fraction decomposition of this fraction is 5 over x minus 1 plus minus 3, so here minus 3 over x minus 2. So this is the partial fraction decomposition of our fraction, which has two linear factors. Let's summarize. We have a fraction with two sample roots in the denominator, 1 and 2. That's to say we have two linear factors, x minus 1 and x minus 2. The denominator degree is greater than the numerator degree. So the partial fraction decomposition of this fraction is the sum of a over x minus 1 and b over x minus 2. All the work is to find the constant a and b. For a, so for a we multiply f of x by x minus 1, and we do the limit as x approaches 1, or we take x equals 1. So this quantity will be 0, and this for this we eliminate x minus 1 and we replace this and this by x equals 1. So this gives 2 times 1 minus 7 over 1 minus 2. This gives 5. Now for b, so we multiply the fraction by x minus 2. So we eliminate this x minus 2. So here and we take x approaches 2. So this term gives 0, and for this we eliminate this. So here 2 times 2 minus 7 over 2 minus 1, which gives b is minus 3. In the next video we will do the partial fraction decomposition of this fraction. I advise you to do it. Start with a and then c. So make b the last. We will find b by two methods in the next video. Thank you for watching and see you soon.